Swayam Prabha. Digital India. Educated India.
Welcome to the course Geology and Soil Mechanics. So, in the last lectures, couple of lectures, we have solved basically 3 problems, and then we will be taking the 4th problem on the relative density calculation. The problem 4 says a sample of coarse sand was found to have void ratios of 0.87 and 0.52 in its loosest and densest states respectively. Okay. The in situ, that means the Emax is 0.87 and Emin is 0.52 if you recall the expression for your relative density. The in situ bulk, unit weight and water content of the sand were 1.95 gram per cc and 23%. Determine the degree of saturation and relative density of the sand in the field given the specific gravity of the soil solid GS is equal to 2.66. So, basically you need to determine two things, one is your degree of saturation, another one is the relative density, and given the loosest void ratio as well as the densest state void ratio. Okay. So, let us solve this problem, problem 4. Now, we have from the definition of the different parameters, that is the gamma B, that is your bulk unit weight, is given by GS plus S into E, that is the degree of saturation multiplied by the void ratio by 1 plus E. Again you can establish that thing, we are not going to that detail. Okay. That means establishing all these relations, because you will be getting plenty of such kind of relation. You can establish the relation among all the parameters. Okay. So, the gamma W will be coming into the picture here, which is equal to GS plus water content multiplied by GS, because AC is nothing but water content multiplied by GS, already we have seen in the last problem or last to last problem, by 1 plus E into gamma W, which can be written as G into 1 plus W by 1 plus E into gamma W. So, this is the relation we can establish among these parameters, and from this few say parameters are known to you from the problem. So, you need to find out the water content. So, according to the given field condition, we have gamma B. If you look at the problem, you will see all the parameters, 1.95 gram per cc, W is 0.23, that is the water content is 0.23, that is 23%, and GS is 2.66. Now, with these values we can put in this expression 2.66, 1 plus 0.23 divided by 1 plus E into 1, from which I can get the void ratio is equal to 0.678. So, this is the void ratio as per the problem given in the lecture. Okay. So, therefore, degree of saturation S can be written as, already we know from our definition. So, SE is equal to W into GS. So, from this if we put the values, we will be getting S equal to 0.902 that means 90.2%. Okay. So, you have got the degree of saturation for that problem. Now, let us find out the relative density. The relative density is given by dr is equal to, you know that, E max minus E natural by E max minus E mean. Okay. So, this is the expression whatever we have seen in the lecture. Now, what is the magnitude of E max that is given in the problem? That is at the loosest state void ratio, that is 0.87, minus E natural. What is the magnitude of E natural? E natural is nothing but whatever value you have just got it, right. So, that is the void ratio in the field condition. So, 0.678 divided by 0.87, and what is the magnitude of E mean? That is also given in the problem, that is 0.52. So, if you calculate the value, it will be coming as, so that is 55%. Now, if I ask you to categorize this type of sand, because this is a cohesionless soil, that means sand. At this moment we are not talking about the cohesionless, because we have not covered what is cohesion and all. Anyway, so this is the coarse sand. So, this coarse sand is having the relative density of 55%. Now, if you recall whatever we have seen in the table, some table was given in the lecture, that based on that you can categorize this sand, and this sand actually as dr lies between 35% and 65%. The soil is a medium sand, medium dense sand. Okay. So, from the table itself we can categorize the sand is like this, because 35 to 65% if your relative density falls, then your soil will be, or the sand will be categorized as medium sand. Okay. So, that is all about your problem 4. So, now we will be continuing with the soil classification system and clay mineralogy.